functional groups, which is the lesson of the day, is going to be pervasive throughout the rest of organic chemistry. Everything that we do is going to depend on what functional group you have. By the way, it asks for how many moles of oxygen, and it said 1 mole of C6H12. So if you had doubled this and got 2, 18, 12, and 12, that would actually be something that would give you the wrong answer of 18. You have to be very careful that it was for 1 mole of C6H12, you would get 9 moles of oxygen. This was actually extremely similar to the first question on the Unit 3 exam. It was very similar to that first question on the Unit 3 exam. If you didn't come for test corrections, I will be giving you back your tests next class. There's still some students who need to take the test because I have given the test back to a bunch of students. Anybody who takes the test now is going to get a different version of the test with different questions. Obviously, because I've given back the test, so everybody will know what the answers were on this specific. So, just so you're aware. All right, here we are. So, Unit 4, Part 2. Like I said, super important lesson today. This is a lesson that I taught in pre-ACE, either in person or you had to watch it on a screen because I had it on Edpuzzle, if you'll recall. Remember that was kind of how we did the last organic chemistry, depending on what class you were in, and if you missed due to the exams. I taught functional groups that way last year, but it was so important that I knew we had to cover it before we were done with the year. So today's lesson, for the most part, will be a review of what you needed to know of functional groups. Next class on Friday starts new information. So everything that we learned last class and everything that we learned today is technically stuff that had been covered in pre-ACE chemistry if you took it with me. Next class starts what's new. So here we go. Identifying, naming, and drawing functional groups. This is one of the most important things you need to memorize in this entire course. More important than the polyatomic ions. If you do not know how to identify and name your functional groups, you're going to be lost in the applesauce for about 40% of the Cambridge exam. That's how important this topic is. So in your what I need to study, put this very close to the top. That's why I want to make sure that we have actually a test before we go to break, because I want to make sure you are tested on this before we go to break, just to make sure you've got them down. Because the thing is that when organic chemicals react, it depends on what functional group they have, what reaction is going to take place. So if you can't even if you don't even know what functional group you have, you're going to have no idea what reaction to do. So this is a super, super important topic. Let's go ahead and get started. Let's go ahead and get started. Here's our objectives. 13.1.2. Understand that alkanes, what are alkanes? Single bond only, right? C and H. Alkanes. We call them hydrocarbons. And they are simple hydrocarbons, the simplest type you can have, and they are defined as having no functional group. I'm the one who bolded or capitalized that, not Cambridge. They didn't yell that at you. That's me. There's no actual functional group on alkanes. Yes. Yeah. Alkanes, what you're going to learn, are super unreactive, meaning they are boring and they don't do much. In order to make an organic chemical reactive, you have to have a functional group. And so a functional group actually changes the physical and chemical properties of the molecule due to adding, either oxygen atoms or nitrogen atoms or halogens like chlorine, bromine, iodine. When we add different atoms, we introduce new chemical and physical properties. And so what you're going to have to memorize straight up, and we're going to go over it all day today pretty much, but what you're going to have to memorize straight up is every functional group. That's on page 26 and 27 of your syllabus, which I have so kindly printed out for you. These are the functional groups you're going to need to know. You'll notice that there's a bunch of different columns there. The name of the functional group and the displayed, the structural, the skeletal structure for each one. The short story is that that has to be memorized, but we're going to spend some time going over each one today. 13.1.4 is directly related to 13.1.3. It's the same thing, except it says know the structural, displayed, skeletal formula for every functional group. And then 13.1.5 is know how to name them. Functional groups. So by the end of today's lesson, you will know how to name things like this. What? It's a friend. It's a ketone, you're right. It's a ketone. No name of what? All right, so with that being said, those are the objectives. This actually seems like not very many objectives, which means that the lesson is actually more. Actually, the less objectives, the harder those actual objectives are. So there's a lot, it's a dense lesson. Yes?
When bringing out the name of a hydrocarbon,
Yes.
do we also include in some way the groups?
By naming it. So like, for example, this is 2-hexanone or hexantuum. I have not taught this yet. I'm about to. So, I just said, hey, memorize. This is you got 2 weeks. Memorize all the functional groups. You get a test in 2 weeks where you have to have all this memorized. Okay? So, that's the short story. You got 2 weeks to memorize all your functional groups. If you took pre-ACE with me last year, I asked you to already memorize them. So, it's rememorize them, please. If you didn't take pre-ACE with me, you have 2 weeks, is what I'm telling you. What? The what? Oh! Which is, oh! I think I know. Hold on. I think I know. But we can do a molecule for that, right? The one where it's shrugging shoulders? Yeah. I'll do that as an example. Sure. All right. First functional group. So what we need to do is go over each functional group, how to identify it. I am going to bring up what it's useful for. That's why I have little images there. Just a guideline of what it's useful for. And then we're going to take a look at the displayed formula, the structural formula, and the skeletal formula for each. So the first type of functional group is called an alcohol. We always start with this one because it should be familiar to most of us. Most people have heard from osmosis in your life that alcohol exists of different forms. There's rubbing alcohol that we use for scrapes and cuts. There's ethanol that's used in fuel at the gas station, and then there's drinking alcohol, which is in wine and beer and stuff. And so there are different variants of alcohols, but in order for a compound to be classified as an alcohol, it has to have a specific organization of atoms, and that's what you have to memorize. There's got to be an oxygen, it's got to be directly covalently bonded to a hydrogen, and that has to be directly covalently bonded to a carbon. So whenever you see R in chemistry, and this is the same for biology as well, whenever you see R, this just means to us the rest of the molecule. The rest of. So the R stands for the rest of the molecule. Meaning that if I have this, is this an alcohol?
Yes.
All of this here is the R group. The OH connected to a carbon is what makes it an alcohol. So that's why I said you might want to highlight or have colors. This is what makes it the alcohol right there. This is, yeah, the first one. So alcohol. could be one, it could be a billion. You don't have any molecules that are that big, but you have some molecules that have a lot of carbons. And so you're looking for this exact part, COH, that tells me alcohol. This is different than the polyatomic ion. You've seen OH before. When you see OH minus, that's different. That is not an alcohol. What is that? That's hydroxide. And that is a base. The difference is that with OH minus 1, it's an ion. It's something that has gained an electron. Whereas here, everything is sharing electrons. So far, so good? All right. So this is a display for an example 1. This is displayed, right? Could we write this same molecule in structural? How would we do it? How would we write it in structural? First carbon, how many hydrogens are attached? So you would write CH3. Next carbon, you've got CH. And if you've got more than one atom coming out, what you should do is write parentheses around it, just like you did for a methyl group. So it would look like this. This would be the best way to write it. And then CH3. This is the structural version. And then let's draw this again in skeletal. Skeletal version. Yeah, it's 1, 2, 3. And then you need a line sticking out with the OH, right? Does it matter whether you put it at the top or the bottom? No. Not really. We usually just go the way that there's not already a lot of stuff, so we usually just write it like that. But you could have done it on the bottom. You need a line going to the oxygen, one straight line going to the oxygen, and then you write the hydrogen. A note, point of note. Remember how we said hydrogens are not written in skeletal form? If the hydrogen is part of your functional group, make sure I get the door. I know you're being kind, but I should always get the door. Safety reasons. All right, just to repeat what I said. Remember how I said last class, in skeletal, you don't write the hydrogens. That's true for hydrocarbons. If the hydrogen is part of the functional group, then you do write it. So because the hydrogen is actually part of the identity of an alcohol, you need to write it, even in the skeletal form. You see the OH and you're like, yes, alcohol. Maybe not too excited. All right, so that's the skeletal, that's the structural, that's the displayed. First functional group is alcohol. You're just looking for OH connected to a carbon. A couple other things that you should know. Is alcohol polar or non-polar? Uh-oh. I'm about to. Polar or non-polar?
Polar.
Polar. This actually very important information because polar molecules are reactive. Non-polar molecules are not chemically reactive. So this actually informs us, first of all, that it is going to be more reactive than other molecules. Also, polar molecules dissolve in water. So that tells us that alcohols will be soluble in water. So what is the intermolecular force? Uh-oh, I'm going even farther.
Okay.
What's the intermolecular force?
Temporary dipole.
No, hydrogen bonding, which is the strongest of the intermolecular forces. You should write this down because Cambridge loves to combine standards. And they can ask you with organic molecules what type of force you have. And it's hydrogen bonding. Every time you have hydrogen connected to fluorine, oxygen, nitrogen. When you have that set of connections, H to F, H to O, H to N, always hydrogen bonding. All right, so we should just diagram this for each of our types of groups just to have it because it is helpful information as we move forward through the class. Polar means it's going to dissolve in water and chemically reactive. So that means later on, we're going to learn a lot of reactions with alcohols. Yes. Okay. Oh, because you came in a little bit late. Sorry.
Sorry, I saw you writing with all the line paper.
Please don't do that. Yeah, you should have asked. I printed these out. They'll make me waste my paper. Don't waste that paper. Bye. $1,000 a year. All right, continue. So, identifying primary versus secondary versus tertiary alcohols. In alcohols, we have a little bit of extra work we have to do. You have to be able to look at an alcohol and determine if it's considered primary, secondary, or tertiary. Now, what does this mean? It's just how many carbons are attached to the carbon that has the alcohol. So, if the carbon is only attached to one other carbon, we call it primary. An example of this would be CH3, CH2, OH. The carbon is only attached to one carbon, yes.
So the one we drew before is secondary carbon.
Correct. Secondary means that the OH connected to the carbon is connected to two carbons. Yes. Go ahead. So the one that we drew here is considered secondary because the carbon that has the alcohol on it is connected to two carbons directly. So we call that secondary. So primary means one carbon, secondary means two carbons, and tertiary would mean three. So what would that look like? An example of a tertiary alcohol could be something like this. Believe it or not, this also matters to reactivity, chemical reactivity, whether you have a primary, secondary, or tertiary alcohol. So this would be an example of tertiary because the carbon that has VOH has carbons coming out on the left side, it has carbons coming out on the right side, and a carbon at the bottom. So in three directions there are carbons coming out, so we call this tertiary. Does that idea make sense? Yes. SN1 versus SN2 reactions in nucleophilic.
Right.
But so how molecules approach and attack the carbon? In another way. We're going to learn that, but not yet. That's not part of our first part of organic chemistry, but it is part of what we will learn later this year. Yes. When Alex gets back. Yes. Perfect. All right. So now that I have explained what this is, at least at an introductory level, see if you can classify each of these alcohols as primary, secondary, or tertiary. This question I pulled from a high school level chemistry book, which means that this is not a Cambridge question. So classify each alcohol as primary, secondary, or tertiary. You'll see what the Cambridge level is shortly.
Oh, I do.
Oh, what?
I'm done.
A. Primary, secondary, tertiary. What do we think? Secondary. So the way you approach it is you look at the carbon that has VOH. The left side has carbons, 1, but the right side has carbons, 2. If the top also had carbons, that would be tertiary. So this is secondary. Or we could just do 2 like that. Or secondary. The lazy in me wants to do this. Cambridge accepts.
Like primary.
1 with a little circle, yes. But it's primary as well. What about this one? So we've got the OH. This is the carbon we have to check, right? To the left, that's actually only 1. Even though it looks like it's a lot, this carbon's only directly connected to one carbon coming out one direction. So this is primary. All right, I think we're going to see a Cambridge question next. You ready? How does this look like when approached to you on a paper 1? So this was what it looks like in a high school level question. Now here's college level version.
You guys think it is?
I'll give you some time to look at it and see if you can figure it out. I'm not going to stand for this one, but I am just giving you a minute to think about it. You want me to check?
D.
It's not.
It has to be D. D makes the most sense. All the other ones are confusing, so I just skipped over them.
I mean, the method of attack, right? So here, that's primary. This is secondary. This is tertiary. It is D. If you want to look, this one is primary.
Yes, secondary. Because there's
This
two of them, so
one-
it adds up.
Is not secondary, right? No. It's two primaries.
But no, there's another one.
Yes. You can go to Janie. Janie,
But there's another one.
someone's here for you.
No, what about the
Go to
one
her.
CUD?
In the back.
What about the one all the way on the left? PH3.
This one, that has no alcohol.
But it's connected. I thought it mattered.
This carbon is connected only to that carbon directly.
Oh, because
This
they're
carbon
all.
is only connected to that carbon directly.
Sorry.
This is primary, this is primary, not secondary.
Yeah, I know.
No. This is primary,
That's the logic.
this is primary,
They're all primary.
this is primary.
You add them up. That's three.
No. That's what you're hoping you will do.
That was the goal.
The answer is D.
Thank you.
It's D.
Yeah, you got add them up.
No. Stop. All right. So the first functional group. Welcome back. Next for the bathroom. All right. Functional group 1 was alcohols. Check mark that. First one. Second functional group. We've got a lot to get through today. The next one you gotta know is called a carboxylic acid. So, carboxylic acid, first of all, has the name acid because of this H. This has two very electronegative oxygens, and this H can actually break off and become an acid, H plus. What you have to know, once again, about every group is its display, its structural, and its skeletal structure. So let's take a look at the display.
It's what? A base.
I'm going to be very clear to tell you the following. When you write the displayed structure, this right here is the carboxylic acid, first of all, the COOH. The functional group, if you look at your paper for carboxylic acid on the back, the actual name of the functional group is carboxyl. So they call it a carboxyl group. But this is specifically a carboxylic acid because it's got the H plus. And so when we name it, we're going to name it as a carboxylic acid shortly. So the display formula is like this. Something you need to know to be pay very careful attention. Cambridge is picky and you know that. If you are asked for a display formula, you have to show every covalent bond. Meaning, you are not allowed to write OH at the end without the line in between. If you write just OH, like how they've done it here. If you just write the OH at the end with the O and the H and no line, they don't give you the mark for writing displayed formula. So the way that I'm writing it here right now is the way I'm telling you it has to be. I've looked at a lot of mark schemes and I've attended a lot of marking sessions with examiners, and that's what they say, is that you have to write it like this. So this is displayed properly for a 2-carbon long carboxylic acid. How would we write the same thing in structural? Yeah.
CH3.
So it'd be CH3. And there's 2 ways you can write it. You can write COOH, or you could write it like this, CH3CO2H. which is just taking the two oxygens and smooshing them together. OO, O2. Yes? Cambridge uses either of these when they present questions. So you need to be familiar with both. I usually write this one. This is my preferred one, but either one's fine. Like you can write either is wrong. What about skeletal? Skeletal. 2 carbons, so we need a line. So a line, and then what?
Out of the second, you need a double line out of the second carbon.
And you have to write what comes out, like
Yes.
what the atom
Oh.
is. If I don't write the oxygen, what does the reader assume?
That's carbon.
That is a carbon. So if you have something that's not carbon, it has to be notated. And if it's part of the functional group, you've got to include it. So O, and then what else?
And then
And then OH. You've got to see COOH in that exact order of atoms. Be a carboxylic acid. Interesting, yes. If you write like just a little tiny dot, you can. You can. To count your carbons, you're allowed to. To count your carbons fairly. For if you're doing skeletal, to write these little dots here, they're not going to count it wrong. Like just to track yourself to make sure that you got the right amount of carbons. If you add 1 extra carbon or 1 too few, you've now given the wrong molecule. So be very careful. Next thing that you gotta know. Is it polar? Polar or non-polar? Polar or non-polar? Which one?
Non-polar. Actually, polar.
Super polar.
Polar.
Very polar. What is the intermolecular force while we're here?
hydrogen bonding.
And because carboxylic acid is an acid, it will actually do acid-base reactions.
Dissolve in water.
Totally, because it's polar and it has hydrogen bonding. So last year, if you took my class, I would say this way because I know if you didn't. But last year or the year before, if you took my class, we did a titration. And we did a titration with vinegar. What we were actually titrating was acetic acid, which is ethanoic acid, which is this. So we were actually doing a titration between ethanoic acid and sodium hydroxide. And we had to figure out how many moles, what was the concentration, but it was an acid-base reaction because this is an acid. And this is actually the acid that's in vinegar. So vinegar is about 5% acetic acid, just an FYI. Or ethanoic acid is the way we say it for paper. There's other carboxylic acids that are ones you should be aware of. Aspirin, the active ingredient is salicylic acid, and that is a carboxylic acid. And then lemons and other citrus fruits have, what is the acid you think is in citrus fruits? Citric acid is the name of the acid in citrus fruits. And those are all carboxylic acids. So could you do a titration with a lemon? Technically. I mean, if you felt like it, right? You want to know the concentration of acid in your lemon? You could do a titration for that. Just titrate it. All right, take a picture real quick, Simone, if you need to. We're about to go on to the next group. So first group was alcohol, COH. Second group is carboxylic acid, which looks kind of similar, COOH.
So the carbon has bond to the same oxygen and
Two
same carbon,
oxygens. The same carbon has to bond to 2 oxygens and a hydrogen following.
and it has to be double bond.
To the one at the top. Yeah. The one at the bottom. Yeah, go ahead. All right, next one. Amines. Here's the deal. At the AS level, after this slide, you're not going to really see much of amines again because there's a whole unit on amines in A level. In AS level, you just have to recognize their existence. So we're not even going to name them. That is all a discussion left for A level. Anybody thinking that? But I do want to bring up what they are because when you do get like practice problem sets, you'll see all the functional groups together, and you do see that it's on the chart here, which means they want you to memorize at least what it looks like. Think of amine. You all have more information than you used to in pre-ACE. Amine. What sounds like amine? Ammonia. What is ammonia that I have asked you to memorize? All right, here it is. Amine is a derivative, and no, that's not calculus. And amine is a derivative, meaning it comes from ammonia. And so the beginning of the word gives you what it is. It's you've got nitrogen in your molecule. That's what it means. It's you've got nitrogen in your molecule. So this is the general formula. It would look like this. Instead of NH3, the hydrogens are replaced by carbons. And so you could have 1 carbon, 2 carbons, 3 carbons, or more. But like I said, you're not really going to do a lot with amines in this class at all. You just have to know of their existence. So if you see nitrogen on your molecule, you've got an amine. You've got some derivative of ammonia. That's the way to remember it. That's the way to memorize it. And so I just wanted to bring up where amines show up. Vitamin B has the amine group. You may or may not know vitamin B is an important one for energy. What? Medicines do have amines in them, some of them, and drugs too. Because if you look here, this is proteins, amino acids. Amino acid means there's an amine. So in biology, amino acids. And then finally here, a class of drugs called amphetamines, including methamphetamine, has an amine. So meth. All right, next one. NH2 with the carbon is amine.
Yeah.
So it goes like that. There is a pattern. Welcome back. All right, next one. Aldehyde. So aldehyde is one of your functional groups that's smelly. That's why it's used in perfume.
We didn't write anything for that.
Not much.
Oh, we wrote ammonia.
Well done.
What?
Well done.
There's different functional groups used in perfume. Aldehyde is usually one of them. All right, so I'm giving you an example aldehyde. What formula am I writing for it?
Wait.
Display. So, general structure of an aldehyde, you've got to memorize, is double bond oxygen to a carbon, a hydrogen sticking out, and then the R group. R group being an amount of carbon. And so, in the display format, you show all your bonds. What does this look like structurally? So in the structural format, actually, absolutely. CH3, CH2, CHO. And you should underline this. And if you need to, tell yourself over and over again, CHO is aldehyde, CHO is aldehyde, because that's exactly how Cambridge is going to present it. CHO. CHO is aldehyde. If you write this as COH instead of CHO, it will be misinterpreted as an alcohol. So you have to reverse the order for aldehyde when drawing it in structural. So notice it's the C, the H, and then you write the O last when you put it into structural format. Finally, for skeletal, let's see what would that look like. It doesn't matter if you start up or down, you just have to do zigzag lines. Whatever, your choice. 1, 2, 3. Now, on the end carbon, Alex, is a double bond oxygen. And then you can, but you don't have to show the hydrogen because it's connected to a carbon. So one way to recognize you have an aldehyde is that you have a double bond oxygen sticking out at the end of a molecule always. So for example, this right here, aldehyde, because the double bond oxygen's at the end. That's a way to figure it out. So when you're looking at skeletal, if you see the one oxygen is the end of a chain of carbons, we have an aldehyde.
What happened to the
Skeleton. Now, question: polar or non-polar?
polar?
Polar. Strongest type of intermolecular force. Not hydrogen bonds. Permanent dipole. So this is where things start to get interesting. It's not hydrogen bonding. If you looked at it from a structural way, you might accidentally think it's hydrogen bonding because you would think the H is connected to the O, but it's not. If you look at the Slade formula, the hydrogen is not connected to a fluorine, an oxygen, or a nitrogen, so it cannot exhibit hydrogen bonding. It has to be just a polar molecule because of the electronegative oxygen, which means that it is a permanent dipole force. Yes? So not as strong as a hydrogen bond. Aldehydes have lower melting points and boiling points. Yes, because they evaporate into the air quickly. So it actually is partially due to its type of information. All right, that's aldehyde. Ready for the next one? Ketone. Oh my, ketones. So displayed. Yeah. Displayed formula for ketones. Where do we begin with ketones? They are super important. I'll explain them in a little bit. First, let's take a look at an example one. A ketone and an aldehyde almost look exactly the same. There's one P difference. Ketone difference. So the difference between an aldehyde and a ketone is that in a ketone, the double bond is not on the end carbon of the chain, but in a central carbon on the chain. So the key difference between an aldehyde and a ketone is in a ketone, you've still got that double bond oxygen, but you've got carbons to the left and carbons to the right. That's the key difference. That's what R and R prime means. Carbon chain going this way, carbon chain going that way. So I've written an example, very simple one, the simplest one you can actually have. This is the simplest ketone that exists. Because you can't have a central carbon until you have at least 3. Otherwise, they have to be on the end. So then displayed is this. What's the structural version? Structural is CH3, CO, CH3. So if you see this in the middle of your molecule and it's structural, that means they have provided you with a ketone. And remember, what's Cambridge's favorite one to write? Display structural or skeletal on a paper 1? They love to present you with structural because you just have to type it. You don't have to drop it. Skeletal version of this. My favorite. That. That is skeletal. Same thing, skeletal version. Notice that the double bond oxygen is not on an end carbon. It's in the middle. And so, same questions I'm asking for each one. Is this polar or non-polar? So, polar, non-polar, it is polar. And what is the strongest molecular force? Permanent dipole. Everybody got it this time. Permanent dipole. Good so far? All right, ketones. Why are they important? So, yeah, it does say here brain fuel. Have any of you ever heard of the keto diet? Keto diet? That actually comes from the word ketone. People intentionally putting their bodies into a state of ketosis, which means that they don't eat carbohydrates. And it forces your body to turn fats into fuel. And when your liver turns fats into fuel, they produce ketones. If you produce too many ketones and you have diabetes, you can also produce too many ketones from diabetes. Then you can actually hit something called diabetic ketoacidosis, which shoots your blood sugar up super, super high because you can't absorb any sugar anymore, and it can lead to coma and death. So ketones What? So ketones are actually really, really important. They're all over your body. If you study ACE biology, you should have already seen aldosis for aldehydes and ketosis, meaning ketones. You should have seen those classifications of molecules and macromolecules. And if you study ACE biology, you'll see aldehydes and ketones again. So ketones, very important. What are we going to need to know about them? Well, we're going to need to know how they react in specific different chemical reactions, actually. And those, again, aren't going to be studied quite yet. So right now, it's just about knowing their display, structural, skeletal structure, and then how to name them. We're going to do in a little bit. All right, ethers. This is another group, just so you're aware. If you look at your chart, I don't even think it's there. So, not on chart. However, so this isn't on the chart that Cambridge gives you in the learning objective, but they exist. Ethers exist. And so I'm not going to pretend they don't exist because it's not in the learning objectives. Ethers aren't tested in AS or A-level chemistry. However, if you were to consider going on to more organic chemistry classes, you would absolutely see ethers. Ethers, the way to memorize them is they're an oxygen sandwich. What do I mean by that? You have a carbon chain, and I keep wanting to do structural, so let me start with this today. You have a carbon chain, and the carbon chain is literally broken up by an oxygen in the middle. Yeah, fossil fuels have to. So ethers, simple. Ethers have this general formula. Why am I bothering to even bring them up? Well, because they exist. And you could see questions where you're asked about an ether, not from Cambridge necessarily. If they do give you an ether, they'll write out what it is next to it. They'll be like, this is dimethyl ether, and then they'll say CH3, OCH3. So you have to know of their existence, but you don't really have to do much more with them. Ethers are oxygen sandwiches, meaning that you've got a bunch of carbons in a chain, but then an oxygen is smack dab in the middle. Just for good measure, write the structural and the skeletal to see what it looks like. I think this might be what you're talking about. Structural would be what? H3, H2, and that's structural. And then skeletal would look like this. There you go, Damani. It looks like that. I see a nose and whiskers. But that's also an ether. So you see an oxygen straight down in the middle of a bunch of stuff, that's an ether. Also, if you look at the board, if you sit in the front of the class, you can see the board, the chalkboard there. It says you either get organic chemistry or you don't, because it's an ether there. That's what that's been saying the whole year. All right. I'm not going to actually really talk. I'm going to leave out the discussion a little bit of polarity here and intermolecular forces because ethers are strange. Ethers are strange and actually tend to be, although they've got those unshared pairs of electrons, the bigger the ether, the more nonpolar it is, actually. So Cambridge leaves this out of the discussion, so I'm going to go ahead and leave it out of the discussion as well. But I did want you to know if ethers exist. Esters. The other reason I bring up ethers is because esters are actually very similar, and this is printed wrong. There needs to be an O here. You need to add in a O there for yourself, because what's there is not a ester. What was there was a ketone, right? Like R-O-R. Add another oxygen here. Esters, you're going to see a lot about esters this year, which I think is very interesting. They don't talk about ethers at all, but the group that's just like ethers, and I guess it's because in, for example, biochemistry, esters are extremely important. in DNA, in different functional groups. Esters are important. So, ester. You've got R, and I wrote it here, COOR. So basically, it's an ether, but right next to the carbon that has the oxygen on it, there is a double bond, oxygen. So that's how you identify you have an ester. You have to have that part right there, COOC, in that exact order of that. C double bond O, and then OC. This is what we call an ester. This is the displayed structure of an ester. Example ester. We're going to name them shortly, yes.
For this one, it says the O and then the double bond O.
That's backwards, but it's the same thing because molecules can be
Okay.
turned around. So we'll see that, I think, actually by the end of today's lesson. Displayed. What's the structure of COOCH3 or CH3, CO2, CH3? Like that. So instead of CO2H, like a carboxylic acid, it's CO2CH3. Tells us it is an ester that's in structure. Anytime you have two oxygens, you can push them together or you could not. Like your choice. What's skeletal version of this? That's it, right? If this oxygen wasn't there, it'd be an ether. When I add the double bond oxygen, it becomes a ester. The name changes slightly as well.
What is there before?
Look there, it's right here. This is 1, 2, 3.
Oh,
Skeletal. Yeah, make sure you're diagramming it, that you understand exactly why you have that exact amount of carbons. Because once again, if you mess up even on one carbon, is not the right answer. So you've got to have it right. Esters. Let's talk about polarity. Polar or non-polar? What do you think? Polar again. What's non-polar? Everyone in these functional groups has been polar. And it has to do with their chemical reactivity. Okay. IMF. What's the intermolecular force? IMF. Strongest intermolecular force here. Dipole again. Permanent dipole again. Not hydrogen bonding because the oxygen and hydrogens are not directly connected together. So permanent dipole. What or where have you might have heard of esters before? You might be wearing one right now. Polyester means many esters. So we're gonna learn polymers a little bit later. Polymers, but polyester means you've got a lot of this in your just all connected together. Bunch of esters. So you might be wearing esters right now. Nitrile. They're there for a reason. Nitrile gloves. Right. When you go do your next lab, look at the box of gloves. It says nitrile. That's a nitrile. And so nitrile is basically C triple bond N connected to a carbon. That's all you gotta know. C triple bond N connected to carbon. So like CH3 C N. Right?
So when this carbon, nitrile cannot be in the middle of carbon. It has to always be on the edge.
It has to be on an end. You're absolutely correct. Nitriles have to be on an end. Because the nitrogen's at the nitrogen's like sticking out at the end. So it'll always be on an end carbon, absolutely. And so to write the structural, it would just be like this. And to write the skeletal, it would be, okay, skeletal is actually kind of weird. I'm going to be honest with you here. You're going to hate it. The correct skeletal for science, for
John, the skirt.
Because it has to be like searched up.
Why? Okay, okay, so here's the deal. How many electron groups are on this carbon? 2, right? Which means if there's 2 groups, the bond angle is 180 degrees. So instead of zigzagging, like we have in everything else that's been trigonoplanar or tetrahedral, we actually are supposed to write a straight line. And put the carbon in the middle. Like, figure out that extra carbon in the middle. Otherwise, you're going to hate that. Yes.
What if the carbon at the end follows?
You would have to zigzag those.
Those would be
So,
good.
like, you would go like that. Afterwards,
But then at the end, it's straight.
But if you put it like the way that we're inclined to look at it. Is it, would
if
it be
you
wrong?
write it potentially, and you may want to do it this way, it's just anyway, so that is the introduction to functional groups. For each of these functional groups, you have to know how to draw them displayed, structural, skeletal, and be able to recognize them. So the other thing you need to do is to name them.
What is it called?
It is polar. And permanent dipole. Yeah. Polar, dipole, again. Wait a second, so why did I even ask you if everything's polar? What's non-polar? Nothing. What? Methane. So going back to the objectives, alkanes are non-polar. The first thing we did last class, that's actually non-polar. All the functional groups introduce polarity pretty much, which introduces the ability, because of partial positive, partial negative charges, the ability for many reactions to take place. In this first part of the unit, we're not going to be doing much reactions, but the whole second part of organic chemistry is all reactions. So understanding why is very important. All right, so we're going to continue. Of course, we have to name. You have to name with each of your functional groups. And so you are going to have to memorize for each functional group you have what the alteration to the end of the name is. A-N-E, you learned was an alkane. E-N-E, alkene. Y-N-E, which they don't test, alkyne. This list right here, and I'll go back to the practice question, but this list right here also has to be memorized. For each functional group, you have to know what is the alteration to the name ending. We'll talk about it shortly, but first, let's see if you can identify functional groups from these structures. This is, you can tell from the font, this is not a Cambridge question. This is from high school level text. So, identify the functional group. Identify the functional group needs the following. A, what do we got? Ether. Because of this. Well, B, what's this one? What's that? Technically, carboxyl, right? Carboxyl is the actual functional group. C. It's a carboxylic acid, but we said that was actually called carboxyls if we ask for the functional group. C. It's called a halogen alkane. It would have been an alkane, but you add a halogen. That's what the name is. It's a halogen alkane. Because we learned halogens last class. D. What's D? What's the type? Tertiary alcohol. They may very well ask with alcohol what type you have. So you may as well just get comfortable with knowing the type. The carbon connected to the OH is directly connected to 3 other carbons, so it is tertiary alcohol. One note I want to bring up before we move forward, aldehydes and ketones. The name of their functional group is not actually aldehyde and ketone because Cambridge is mean. It's my favorite. It's my best way to interpret that. In the new standards, take a look at aldehyde and ketone on the paper. What does it say the functional group is?
AL.
They're both called carbonyl. So you're gonna wanna maybe go back here real quick. Aldehyde, the actual name of the functional group is carb. I agree. And they react differently. Carbonyl.
That would be confusing.
What that means, what does carbonyl actually mean, just to be clear? It means that you've got C double bond O. That's what the carbonyl group is. Carbonyl. Ketone also, the functional group's actual name, if they ask you for a point, what is the functional group and you've got a ketone, it's actually also carbonyl. Write that in your notes. Again, it's because it's a C double bond O. The only difference between the two is if the carbonyl is on the end, then it's actually an aldehyde. And if it's in the middle, then it's called a ketone. So once again, there's a paper here that I passed out, a handout. Everything here technically has to be memorized. All right, next thing. Back to naming. Good news, bad news. Bad news, you got to memorize all the ways to name your functional group. Good news, if you can identify your functional group, then you can name it. Alcohols, you change the ending of the name to all. Naming. Ketones, you change the ending of the name to on. So far, so good? On. Ketone, on. Your test is on paper, who cares? Aldehyde, you change the ending of the name to al. Carboxylic acid, you change the ending of the parent chain to oleic acid. Oleic acid. Amine, no longer tested, so I'm not going to put it on the test. So skip. Hey, I took one thing off for you.
Yay.
Ester is the hardest. I may have to explain it next class if we don't run out of time today. It's ill 08. I'll explain that when we get there. Ether, also kind of irrelevant, right? Because ethers are not in the standards. So alcohol, ketone, aldehyde, carboxylic acids, and esters, you absolutely actually have to know how to name them. Let's take a look at them. Name the following. So getting to it.
That's
How many carbons are here? I know it's written kind of wonky, but there's one here and two there. What's the prefix for two? Ethane. You drop the E. So just to go through the process, ethane would be 2 carbons long. Drop the E and add OL because it's an alcohol. So now it's ethanol, the type that's used for fuel. Ethanol. That was our first example. Take a look at another one, maybe written more the way that you could see. What about this one? Try one more alcohol. How many in the chain?
4.
So it would have been butane, but drop the E. Now it's butanol. But because the alcohol, there's an option of where it could be, right? It could have been on carbon 1. It could have been on carbon 2. So it's going to be on carbon 2. So you can write this one of 2 ways. Either buten-2-ol or 2-butanol. Usually it's presented this way by Cambridge, but either way is okay. I would have both just so you know that those are the 2 possibilities when you ask me, Miss Ruth, is this okay? I'll tell you if it's one of these 2. Yes. come up with something else? No. One more alcohol. Oh, let's have some fun. What's that?
Use 1-0.
Buttes and or something.
Go ahead, Justin.
Buttes and or.
Cyclobutanol. Cyclo in a ring. Butane, 4 in the ring, right? And there's no other option for where that alcohol can go. It has to be on carbon 1, so you don't put a number. So that's something important to note. You only put a number if there's an option, like a different possibility of where it's going to be. So it has to be on carbon 1 and the ring. That's it. Cyclobutanol. Yes? Spice it up one more time. I heard. Okay. What about this? Go ahead. Almost. Go ahead. Hexen. 1, 3. There's 2 of them, so you would actually say diol. That's okay. That's as spicy as it can get. That's as spicy as it can get. See, though, it's heading for PZ level of difficulty.
So we could also write 1,3-cyclohexadiol.
Absolutely. Remember, anytime it's here, it could also be written in the front instead. If there's an option of di means you've got 2 alcohols. If they're both on carbon 1, there were other options of where the second one could be, so you have to say it. You have to say they're both on carbon 1. However, I don't think I've ever seen a 1,1 cyclohexane diol because the OH groups are so electronegative that they would repel each other. You don't want to see that. All right, next group. What's this? What's this? What's this? What's a functional group here? 1, 2, 3, 4, 5. But what's the functional group? Well, I mean, the functional group is carbonyl, but what is the actual thing? What is this?
Aldehyde.
Aldehyde because it's on the end. Aldehyde. That tells us the ending has to be Al. Are we okay with that?
Yes.
Once I found out it's aldehyde, I know the ending has to change to Al. So now count the carbons. I've written little dots on them. How many are in the chain? Something to note, really important. A functional group that's at the end of the chain has to be on carbon 1. You may want to write that. A functional group on the end of a chain either on the left side or the right side, doesn't matter. On the end of the chain is going to be carbon 1. Be careful with that, because otherwise you may number the wrong way. So the aldehyde gets carbon 1. Functional groups get priority. So we know this is 5. 5 used to be pentane, but you have to drop the E, and now we call it
Pentanol.
Al. Another note, Cambridge really picky right here. A versus O. Those letters look very similar. Your handwriting is not great. Make sure your A looks like an
Pardon the interruption.
yes. Yes.
Hi, can I see Hakeem? This is Ms. Haran.
Okay. Yes.
Thank you.
All right. Make your A's look like A's and your O's look like O's, because pentanal and pentanol look just like each other. Right? They will be very picky here. Pentanal. Question for you. Do I have to say pentan 1 out?
No.
It's inappropriate to do so. Why?
Because aldehydes always have it at the
if it has to be somewhere, you don't put a number. Yes. Pentane has no aldehyde, right? Pentanal has a double bond oxygen at the end here. This is pentanal. All right. What else is on this molecule? We haven't finished naming it. On carbon 3, we've got a methyl. So 3-methyl pentan Al. Make those A's clear. So the moral of the story here, if you can figure out what your group is, it hopefully shouldn't be too hard to figure out the new ending. This was difficult? What's difficult is the memorization.
Yeah. I don't know what's the thing. Yeah.
What's this? What's this?
2, 3, 4, 5, 6, 7. Odd number.
Okay, an odd number. 10
Al.
A-L. All right. I want to make a note here before moving on. Cambridge has directly specified that they will only test simple molecules. What do they mean by that? Like, what does simple mean to Cambridge? 1 or 2 substituents. Like, when they test you for naming functional groups, they'll give you 1 substituent or 2 substituents, but you're not going to get anything like you got in previous chemistry, like 1, 2, 3, 4, 5, like 1, 2, 3, 4 tetramethyl. Like, remember how some of those molecules were like all over the place and you had to like count along the carbon chain? They said simple, 1 or 2 substituents typically. When there's functional groups, they're not going to give you anything crazy. Yes. Technically, yes. So that you understood the rules. Yeah, those questions are actually more difficult than anything you would see in ACE. Yes.
This is so much fun.
There was like 2 different, there's also like OH.
It would be carboxylic acid like this. If you did this, carboxylic acid, oleic acid ending now. All right, let's go on to the next one. Hey, look at that. What do we have now? What's this called? Carboxylic acid. So what's the new ending of the name? Oleic acid. So what is this? It was butane. E gets dropped. Butane. Oleic acid. More carbons, carboxylic acid, that's the name. All right, we're okay with this?
Yes.
Next slide is a paper 1 question. Ready to see it? Here it is. Which diagram gives you the skeletal formula of 2-chloropentanthreol? See how far we are into the lesson. Work it out, see if you get it. While I check to see how far into the lesson we are. Ooh, we're pretty far. We're doing well. We're doing well. All right. So, pentanthreol. How many carbons in the chain?
5.
So, are there any answers we can take out immediately? Five. Right? 50-50 chance now, based on the carbon chains. This definitely doesn't have alcohol on the 3rd carbon, you agree? This one does. It's A. If you get a question like this on an ACE exam, it's a blessing. That's about as easy as they could possibly make it. All right, draw now. Draw. So, they're asking for the structural formula. Just like in regular naming, you may have to name, you may have to draw. You're being asked for the structural formula for hexane 2-ol. So there's a couple different ways you could go about this. You could start by doing the display and changing it to the structural.
Oh.
Or, pay attention, you could also do the skeletal first and change that to the structural until you figure out how to count the hydrogens properly. Hexantuol. So what's the structure of that? I'm going to do the carbon backbone. How many carbons do I have? 6. So far, so good? On carbon 2, what do I have? OH. This is enough information, the skeletal format, to allow us to translate this to a structural formula. The first carbon would get how many hydrogens? So we could do it like that. CH3. And we've done that. The second carbon gets how many hydrogens? And then you would write the OH in parentheses. Now we've done this one. Notice how I'm going about it? The next one. Isn't this CH2, CH2, CH2?
Yeah.
So you could group that all together. You don't have to, but you could group. You can either write CH2, 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 or you could write CH2, 3. And then at the end here is CH3. Yes? All right, how do you feel about that? Okay. Questions, comments, concerns, fears yet? Just constantly scared? Yes. Question, Peter? Let me check. Because they interpret it as, they interpret that as 3 of those. That's what they interpret it as. So no. All right. Hex and 3-on. What do we do?
Okay, so
1, 2, 3, 4, 5, 6. What does on mean? Double bond O. Carbon. Free. So far, so good?
Yep.
Once I've got my backbone, we call this our backbone, then you can easily count the amount of hydrogens you need on each carbon. Carbon 1 gets how many hydrogens? 3. Carbon 2 gets how many? So if I miss 1 hydrogen, my full answer is wrong. Be careful. Carbon 3 gets how many hydrogens?
0,
So it's just CO. Carbon 4 gets how many hydrogens?
2,
Carbon 5.
2,
And last one? Good? All right. Hexan al. What's that? Aldehyde. It's easier to write aldehydes on the right-hand end. It's kind of wonky to write them on the left-hand end. It can be done. You got to do a backwards shell. So I usually write them on the right-hand end. This is an aldehyde. CH3, CH2, 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 or we could have grouped that all together, and then CHO. Sure. Yes?
Yeah, that's it.
you want to connect to
The hardest part of this lesson, honestly, is knowing your format. Most of this lesson is learning formatting. This one and the last one. Formatting and naming.
saxophone.
You need we have enough time to talk about esters, so we're going to. This is so that we have time for isomers next class. Isomers need love. It's a new topic. So,
Not CHO.
before we get to that, there's a couple questions here. Draw the following. Skeletal. Yay! 2-butanone. How do we do that skeletal? 4. On the second carbon, left or right doesn't matter, but it's got to be the second. You put a double bond oxygen. 2-butanone. Propanone. Propanone. Prop means how many carbons? 3. So 3. And and there's only one option for where that double bond oxygen can go. Level 3 hexene sounds to me like an alkene. What do we do there? Hexene. 1, 2, 3, 4, 5, 6. 3 means between carbons 3 and 4 is where your double bond is. So make sure you're careful with that. Between 3 and 4, double bond. And on carbon 2, methyl. Make sense? Good with this?
Yeah.
All right. So breathe in, breathe out. You got it. Breathe in and breathe out. We gotta do that.
Would this be fine for the? I just go like.
Yeah, I understand that. It's fine. Let's see. Is this Hakeem? Welcome back. Okay, so naming esters. Final part of the day, really. I mean, we're gonna do nitrilyl, I think, but this is the big last thing. Esters are a group that is going to be tested. Cambridge loves esters. Like, there's a lot of questions on esters. So, here's the way to memorize how to name esters. First of all, the problem with esters is that they are smack dab in the middle of a carbon chain. You don't have, like, just carbons in a row. You've got an oxygen somewhere. So, whenever you have an ester, you have to imagine that it's broken into 2 sides. One that has the double bond oxygen, and the other side has the single bond oxygen. So that's what you're going to be looking for. So we say we make a cut where we have between the double and the single bond oxygen. The side that has the single bond oxygen, we call that the ill side. The ill side. So you count the carbons. This is 2 carbons. So this would be ethyl. So it gets 2 names. The side with the double bond gets the ending of the name is OH. So the side with the double bond carbon, that gets the OH name. So this has how many carbons in a row?
2.
On the left side.
4.
4, right? So this would be butane.
Oh.
No wait. So then I wrote here, and I did it on purpose. Esters are actually made up of an alcohol that is combined with a carboxylic acid. An alcohol combining with a carboxylic acid actually makes an ester. We're not doing the reactions yet. That's later on. But if you were to combine an alcohol and a carboxylic acid together, you would get this. And so that's why I call it the alcohol side, and I call it the carboxylic acid side, because it's the part that derives from. If you've studied biology, I always bring this up because I know there's one person in this class that is taking ACE biology. You have already studied that reaction in dehydration synthesis. It's something that you do in ACE biology. You study that reaction there before you're going to see it here. But the idea is that you can actually combine, and I'll just show you real quick. You can combine a carboxylic acid and you can combine an alcohol together if you want to just have a heads up on where you're going to go later on. It's a double replacement reaction of sorts. You take out the OH from the carboxylic acid, you take out the H from the alcohol, and guess what you're removing? Water. Which is why in biology they call it dehydration. Because you're losing water. But when you combine this together, you take out the water, you move everything else together, you get CH3, CO, OCH3. There's a lot of important esters in your body. That's why it's a very important reaction. You don't have to memorize this right now. It's coming later in the class. But I'm just trying to explain why I've said it this way. For the purposes of what we need to do now, in naming, all you have to do is look for the side that has the single bond, call that ill, count the carbons. The side that has the double bond, call that OH, count the carbons. So that's what you're going to have to look for. Yes, Ben?
Could it also be correct if I put
have to make your cut for your two sides at the carbon that has the two oxygens between the carbon and the oxygen. That's where you make the cut in here. And then you count how many carbons are in each side. So we of course got to do one, right? We got to do a few just to make sure we kind of have an idea of what's going on here. All right, so remember, esters, ill, oh wait. Where's the cut?
After, right here.
So it's right in between this carbon and this oxygen. It's going to be right here. Which side is the ill side here?
The side of the O, so that way.
Which side gets the OH ending? So count the carbons for the ill side. How many? 1. Prefix for one carbon? Meth. So methyl. Right? 1 carbon equals meth. So it's methyl. On the other side, I'll take a look at it. I believe so, except you have to do the pentane and just drop the E.
Oh.
Remember, it's 1, 2, 3, 4, 5. So that would have been pentane, but you dropped the E and changed the ending to OH. So the name of this is methylpentanoate. You're welcome. Methylpentanoate. Pentanoate. Good with this? Yes, Jamie. Go ahead. Take a picture real quick. We're going to do a few more examples. Yeah, for sure. So, what if you, oh, you need to go back. Let's do one more, just to spice it up, like last time a couple slides ago. What is, what's this? You're welcome.
It's the same thing.
It's not the same thing. How will we name this? How will we name this? First step, make the cut. Where's the cut now? So be careful here. This is where your cut is. Between the carbon and the single bond oxygen. This is the ill side, the left side. Because the single bond oxygen's on that side. You gotta be careful because sometimes it'll be reversed. And this side would be the OH side. So then how many carbons are here?
3.
Propyl. How many carbons here? Prefix for 2?
F.
Ethanoate. So it's ethane, but then you drop the E for the OH. Propyl ethanoate is the structure of this one. All right, what about looking at it in a different manner? What if you saw this? Can you name it here? Can you figure out what's the ill side and what's the OH side from looking at it structurally?
Carbon monoxide.
Got a lot more going on. The CO's there, but notice, remember CO2, that means it's COO, right? Here's what I would suggest. If you're given structural, I would expand around this carbon. Meaning I would rewrite it as CH3, CH2, C. What happens to these two oxygens? One goes up and one goes to the side. So it's like this. Once I've rewritten it this way, does it make it much easier to see what's my ill side and what's my OH side? So where's my cup? So this is my ill, this is my OH. How many carbons here? Methyl. How many carbons here? So propa, propanoate. So it's methyl, propa, no wait. This functional group is tested a lot on Cambridge, both paper 1 and paper 2. So definitely know the structure. That's why I'm spending time with half to come up with the name. There's one more. It's gonna be quick, thankfully. One more functional group that we have to know the name of. It's gonna be quick. It's called a nitrile group. Nitrile. Yes, it's on the back. I said new functional group because I don't teach it in pre-A, so I know that for some of you, all of this is new. But oh, before we even get to nitriles, there's one more slide here. Write the skeletal for each of the following, right? Ethyl butanoate. So how would we write this? Ethyl butanoate.
So 4 carbons.
Okay. 1, 2, 3, 4.
And
Then
that carbon
this.
is- oh,
Then this. And how many carbons on the other side?
yeah. 2.
What if you wanted to go the other way? Like, do you have to write it this way? Or could you have started with the ethyl first?
You
Like,
could start with that first.
you could have done it like this, then went to the oxygen, right? Then went to this, and how many carbons would then have to be on this side?
4.
Yeah, same molecule.
That's the same thing.
It is the same thing. This is ethyl butanoate, and this is also ethyl butanoate. Either way, both are correct. And the other one, welcome back. Sorry. The other one is methylpropanoate. So, do you want to do the oxygen on the left side or the right side? Just give me advice. Left side? Okay. So methyl, so that's just reading it. 1, then oxygen, then double bond carbon, then this one is one of the 3 though. 1, 2, 3. That's it. Methylpropanoate. Oh yeah, it does look like it happens. What? How do we do that? All right, last section, nitriles. Janie, do you need to take a picture real quick? I know you just came back from the doctor. What? Almost done. Nitrile groups where you see the C triple bond N. Something about this group you need to know. This is always carbon 1, right? On the chain. And is part of the name. You have to count it in the name. So when you're naming nitriles, you count the amount of carbon. 1, 2, 3, 4. You write the name of the alkane. It's really weird. And then you just write nitrile at the end. So it's butane and then nitrile. This is 1, 2, 3. Propane, then nitrile. So this has a substituent, so it's got the 2 bromo there too. Right? So ethane nitrile, let's see if we can write it. Ethane, how many carbons? It says skeletal, how fun. Remember what I told you about skeletal and nitriles? It's like that, right? And then like that because it's a triple bond to the end. No, it doesn't look right, but it is.
Oh, that's how you do it?
Please pardon this interruption. Students, this is a reminder that tomorrow is the Algebra 1 Best retakes. The lists have been posted in green. Additionally, the student who is missing the FAST, you've been advised you will be in 249. Students, please remember that these rooms are cold. Please bring a jacket, a sweater, and be ready to ace this test. Thank you.
Pentane nitrile. 1, 2, 3, 4, 5, right? Carbon 1, carbon 2 needs a methyl coming out, so something like that. Those you're not gonna love it. What looks better displayed? Just saying. This display would look a lot better. So if you get a choice, you draw it how you want. This is how the same thing for ethane nitrile would look displayed. So many lines. All right, so believe it or not, you all were able to finish all of functional groups. That's everything you've got to know. There is homework. There is multiple homeworks on this because you've got to memorize them real well. So the only way to memorize is practice over and over and over again. I'm passing out the homework. You can get started or take a 10-minute brain break. You paid very good attention, so you deserve a 10-minute brain break. Or if you feel good to start, feel free to start. Okay. When did that happen? You have to. You can always keep a record. So what you're wearing now, it's black, like it's black, so it's fine. You've got your CIA logo, so it's okay. If you have something fancier, it's preferred, but that will be okay. Oh. Who is that? Right, did everybody get a copy of the homework? No, this is weird. It didn't. That's not supposed to be. I don't know why this prints like that. Like the black box. I don't know what that is. It's supposed to be just a card. Yeah. I don't know why. I don't know what happened.
He's my favorite. Exactly. He's just underused. Because they just I don't know why Chase do everything. I hate Chase so much.
Okay. He's better though.
I don't know what happened.
Base.
I used your lesson.
That was really good.
No.
That was really good.
No, tracker.
Super Rocky.
Oh, the water wants you.
I don't understand.
I know what you think.
Marshall. I did it.
That's water.
Rubble.
They all do, but that's not the thing.
No, it's math. In the last match of the game, it's just like I have to cheat. No, Rocky's still scared.
Okay.
For everything.
Yeah, because Ryder is lame and he hates it.
It's annoying.
To me, Ryder is racist. There we
You
go.
don't remember it's in the middle.
Yes.
It's the Alta. He's the Alta type.
Always chase them. He is the one who trained Zuma for the water. Yeah, let's remember this. He trained all those.
Okay, so the box means nothing. It's just some weird thing. It's been like that on
Yeah, no, it's always chase. It's always chase. That's Chase's guy. I can't chase. They're gone. No, they're not.
There's a reason you train them to do more useful things.
Came to the United States, he would be immediately arrested. His kid was dead. Not saying Chase especially the better police.
No, Chase sucks. He's so uptight. He's so lame. He had one scene in the movie.
Maybe.
Well, I didn't see the movie.
Hate is online.
Yeah. I've only watched the show. And I only watched like 2 seasons of it.
Yeah.
I watched it.
Yeah.
No, because I'm not.
Oh yeah.
Your first one's
I watched it.
correct.
Actually, I didn't. I watched it with my older sister.
Okay? Tired?
You're gonna lose in less than 10 minutes. These 10 minutes.
That's a brain break. That's like
Oh,
That's how you
because
make
you
your
believe
friends.
that he is. I think I just put violence. You think?
So you all hang out for like an extra 15 minutes in the tutoring. So
Yeah.
you earn extra.
I'm fine.
It stays at 3:45. Which I'm supposed to kick everyone out at 3:30. Yeah, it was
We
later.
got out at like what, 4?
Yeah, and that was,
I can see what fits in that. I love before.
I still had to set up the lab after that. I was still here later. Yeah, somewhere around there. And I still stayed like another hour setting up the lab.
Vincent, are you cold? Well, you want another dragon? No.
Oh, you should get black pants. Because you have to. Yeah, if it's all black, yes. Your outfit.
No. I have a personal fear, apparently.
What?
What kind of art is that?
I would say it's carboxyl.
It's
Like if
it's
Cambridge
spelled with
asks,
cards.
you should
I added
say
them to the
carboxyl. So like for aldehyde, when Cambridge asks,
You're gonna go
you
crazy.
should put carboxyl. For the grounders, and they say the lyrics functional groups, it would be carboxyl.
That I messaged.
Aldehyde is the specific, like what it actually is. They call it the homologous series.
Has to relate to like school.
By the way, whenever you see the black line here,
I can't,
they've changed something.
not even if I wanted to.
So this is to the new syllabus, that they've never changed this.
There's no need to
Straight printed from the Cambridge syllabus. So you'll notice a lot of dashes here, because they changed them. They specifically changed them when it comes to aldehyde carboxyls, and you need to call carboxylic acids carboxyl. Specific. If it was a Cambridge mark and they asked functional group, you would need to call this carbonyl and yeah, you would call it hydroxyl. Yeah, you could. Like put a black.
What? I didn't lose it, I have a.
Yes.
That's not my fault.
On your
Part of the cards. Did you guess?
What is that game?
Yu-Gi-Oh.
Yu-Gi-Oh.
Oh, you're playing two.
You have a chemistry?
You shouldn't do that. That's the only answer I got. You shouldn't do that.
And you're taking the test now.
I got a good hand. But there's no need to do that. What you're about to do, you don't need to do it. You still did it. More study. Why are you like this? What other cards do you have? You have Tool World, right? That's useless. I mean, you can't attack me, right? Right now? Yeah, right now.
You gotta know your ID back now.
What if I did? You can't hit me. I know you can't hit me.
How do you feel? Overwhelmed?
Excited.
So that means you gotta do a lot of practice questions?
Good afternoon, Gold Line. This is Nicolas Garcia, and these are
With
your.
functional groups, you've gotta do a lot of practice.
Yeah, you students, here are a few important reminders.
You gotta
The
kind of
appropriate
get
school
it in
uniform
the
and
right.
outwear must be installed.
I'll study in my own way.
Last year, the uniform was worn Fridays.
Study what we're
School
doing.
polos should be worn Monday through Friday.
If you wanna be a part of
Should be
it,
purchased online
like
at
the start of
iBelly.com
it is
or at the
functional.
Kindle
You
location.
gotta know all the
Wear a
reactions.
student ID badge around your neck at all times.
So functional.
Arrive to school on time between 7:10 and 7:15 a.m.
I mean, I can't.
Here's the discipline plan. Is in effect for dress code and tardy violations. You may only eat lunch either in the cafeteria or at the picnic tables outside, no eating in the hallway. If you bring a bike to school, make sure you bring a lock and lock it up. The south side of the building is not accessible until further notice. All pickups and drop-offs are conducted in front of the school. Take this into account when leaving a few minutes early to arrive at school on time as traffic will build up.
I play a different
Saeed
Saeed.
participating in the Do the Right Thing program. The entire school staff is keeping an eye out for students who do the right thing, such as preventing bullying, reporting reporting a threat, showing exceptional kindness, or participating in the crime. Nominations will be submitted. Each nominee receives a certificate, bumper sticker, letter of congratulations, and Thomas John P. certificate, and each of nine. Yearbooks are on sale now for $60. Prices increase afterwards, December 20th. Please visit www.yearbookordercenter.com. G1027. It's NHES. NHS is collecting toys and sensory games for students of Neva Kingdom.
I know damn well you guys are just never leave a kid.
Toys must be new and not wrapped. Donations will be collected in the office in this building. Service hours will be awarded 5 hours per full day for a maximum of 20 hours.
And I'm gonna kill him with our first double. Less than 10 minutes. I don't think that's only the labyrinth. I did not. They make my so much stronger. We can't die.
That's mine. That's mine. This ain't mine. This is mine. No. I don't care. This is mine.
And then first in the morning, you're like,
I think sequence with Razor, they are a little bit over. Because see, this thing can like sit, you gotta take and not be discovered. And it can like
that's still something. It's a lot of stuff.
Liking cards? I got booking cards.
All right, everybody, have a wonderful day. See you Friday. Friday, we're doing something new. Something new on Friday. Have a good day. All the stuff from Prius has now been reviewed. In terms of organic, everything we do now is new to ACE. Isomers. It's called isomers. If you want to look it up. We're only doing structural isomers, I believe, on Friday. Because optical isomers are definitely, it's geometry. It's like knowing angles and shapes again. So isomers is the next time. Isomers.
Let's say this way, what happens to the air span when there's 685 to the wet 3 have 70% accuracy of the aircraft? They die.
Bye.
The 85s that have all like 10-37 seconds out. And let's say this way, yeah, the aircraft go.
Have a great day.
Oh, is it too
Bye. Okay,
Someone left their phone. Someone left their
Oh
phone.
no. Is that your phone?
No?
Somebody left their phone. Is it Julio's phone?
Maybe.
Is it Vincent's phone? Oh my
Whose phone
goodness.
is that?
Yes,
I forgot to turn this.
please turn it in.
I'm so sorry.
It's okay.
Bye.
Do you happen to have any pets?
What?
Any pets?
Pet? Not at the moment.
Okay, because
But
I
I, huh?
can draw something in return.
I love it. It is.
I wish I had a parrot though.
It's very different than Instagram.
Bye.
Is it organic? Is it changing? Different. Any more math? Bye. Have a nice day. Oh boy.